Continuing with composition of functions, we have h of x is 3 minus x divided by 2x plus 4. And j of x equals 7 over x. We're going to find j composed with h of x and its domain. So, j composed with h with an input of x can be rewritten as j of h of x, like this. And the inside, what j is operating on, is now h of x. So we can rewrite it like this. So this is j of 3 minus x over 2x plus 4. Okay. And if this is hard for you, we come over here and we do some scratch. If you can do this right away, skip through this part of the video, just fast forward. So j of 4, remember now I'm replacing this x in here is now a whole lot more interesting. So I'm going to replace this x as well with the new thing. So if you're not comfortable just jumping straight into this one, let's do some baby ones over here. So j of 4, well, that's 7 over 4, right? This was j of x is 7 over x. So j over the input is what this really says, right? Well, my new input is 4, so this is 7 over 4. Let's do another one. J over 123. Well, that's going to be 7 over 123. My new input goes on the bottom. J of 91 is 7 over 91. If you're wondering where I'm getting these, I'm just pulling them out of the air, making them up, just to show you the pattern, right? Whatever the input is, it goes on the bottom. 7 over the input. I'm just going to do enough of these to make sure you're comfortable. We're going to lull you into complacency. So j of negative 19 is 7 over negative 19. J of 51 is 7 over 51. Excuse me. J of 116 is 7 over 116. J of 137 is 7 over 137. J of 3 minus x over 2x plus 4 is 7 over 3 minus x over 2x plus 4. See what I did there? Just when you started to get bored, I threw in the one we were looking for. And hopefully you were able to do it, right? We notice when we start to do routine tasks, our brain shuts off and turns into like autopilot. So then I threw in the more challenging one, and most of you are probably able to do it. So I'm just color coding so you can see. Color coding kind of distracted from noticing the pattern, but hopefully you see it. So this means that j of 3 minus x over 2x plus 4 says put 7 on top and put this on the bottom. That's what this function does, right? Whatever the input is, 7 is divided by that input. So this is 7 over 3 minus x over 2x plus 4, like this. So take just a moment and look at that and make sure you see where that came from. Okay, so now we're going to clean up this fraction. So I'm going to rewrite it a little bit differently. This is my numerator and this is my denominator, right? I can also write the numerator as 7 over 1. Is that legal mathematically? It is, right? Any fraction I can write over 1, any number I can write over 1 and make it a fraction. Okay, so how do we clean up fractions? So let me remind you. To clean up a fraction divided by a fraction, there are 2 steps. A lot of my students tell me divide by or multiply by the reciprocal. Make sure you know which piece. There are actually 2 fractions here. Which one do I multiply by the reciprocal? Which one do I leave the same? What do I do? So please practice using this correctly. There are 2 steps. The first step is rewrite the fraction in the numerator. And then step 2 is multiply by the reciprocal. It's a fun word, right? Reciprocal of the fraction in the denominator. So we have 7 over 1 divided by 3 minus x over 2x plus 4. We're going to rewrite the fraction in the numerator. So I'm going to rewrite this as 7 over 1. So that's this step right here. Now I'm going to multiply by the reciprocal of the fraction in the denominator. So I'm going to multiply by the reciprocal of this. Reciprocal means just flip it, right? Flip the fraction. The numerator becomes the denominator. The denominator becomes the numerator. So I'm going to get 2x plus 4 on top and 3 minus x on the bottom. Does that make sense? Hopefully it does. Now we have a fraction times a fraction. When you multiply two fractions, you can multiply numerator times numerator over denominator times denominator. So we can really simplify this as 7 times 2x plus 4 over my denominator of 3 minus x. Some of you may be wondering where the 1 went. Well, 1 times anything is just whatever you had to begin with. Okay, and then we can clean up. A lot of students want to distribute. You could probably leave it like this, depending on your homework system. I would take it factored, but if you want to distribute, that's certainly fine. 14x, and then 7 times 4 is 28 over 3 minus x. So this right here is our function j composed with h of x. Okay, and that is simplified. Now let's find the domain. To find the domain, we check two pieces. That's what this box up here tells us, right? To find the domain of a composition of functions, now this is f composed with g of x, which we know is f of g of x. This right here is the inner function. Okay, so it says find the domain of the inner function. Well, in this example in the box, it's g of x. But our example, the inner function is h of x. Okay, so we need the domain of the inner function. And then we're going to find the domain of the whole simplified result. Okay, so domain of the inner function is right here. So this is piece 1. The inner function is 3 minus x over 2x plus 4. When I say inner function, I'm talking about the first time I wrote j of something that I plugged in the h of x right here. Okay, so what's a fraction, right? Rational functions have a domain where their denominator is not 0. So denominator can't be 0. The denominator here is 2x plus 4. So we're going to solve for x, move the 4 over. So 2x cannot be negative 4 divided by 2. X cannot be, well, negative 4 divided by 2, that's negative 2. Okay, so if I think about a number line, I'm going to see negative 2, and I'm throwing out negative 2. I'm allowed to have everything else on my number line. Remember, your number line is like the x-axis. So this is x cannot be negative 2. Now I check the final simplified result. So this was the inner. Now I'm going to look at the simplified result. Well, the simplified result was 14x plus 28 over 3 minus x. Again, this is a rational function. So we make sure the denominator is not 0. A lot of students confuse that and want to say x cannot be 0. That's only true if x is the only thing in the denominator, right? Or a factor of the denominator. We are finding the denominator cannot be 0, so 3 minus x cannot be 0. Move the x over, 3 cannot be x. So let's look at that number line. So I'm going to go and put negative 2 on here, even though it's not part of my problem. Just sort of a point of reference. So if x cannot be 3, I put an open circle on 3 and I shade everything else, right? But if I want the domain of my composition, it has to satisfy both of these pieces. So I can use this section of the number line, which is what? Negative infinity to negative 2. Let's talk about why I used parentheses. Well, infinity and negative infinity are just concepts. They're not numbers. We're never really going to get there, so we have to use a parentheses. We do not include negative 2 because it's not included in the top number line. We had to throw it out when we found the domain of the inner function. Okay, union. Then we look at the next piece. The next piece is between negative 2 and 3. We had to throw out negative 2 from the top number line, and we threw out 3 from the bottom number line. So we use parentheses on both. union, and then the last section, 3 to infinity. Parentheses on both of these because we threw out 3 and we're going to infinity. So this is the domain of that composition.